Hello and welcome to this new C programming tutorial. This is part 7 on how to program in C. In the previous tutorial we learned how pointers work, we also learned how to call methods, how to define methods, and we also learned how to print cool patterns on the screen. So you can save the code as always, but I will delete it in order to continue. And in this tutorial, we will learn C structures, which are the part of C that we can use to do object-oriented programming. Okay? So basically, a structure is a kind of a tool that enables us to define an object and some of its properties. Okay? For example, if we want to define a book, and a book has different characteristics like title, its author, subject, or the book IB, the book price, maybe if we want to sell them, and all of that. So for example, to do that, we go and say struct, and I will call it books. Okay. Okay, I will open a bracket, and inside these I will define the features, if you want to call that way, that books have. Okay, for example, we're gonna create a char array. We will call it title, and it will be maybe 40 characters long. Okay, and then we can do something like the book author, and we can say the author would be also maybe 35 characters long. So this can vary depending on our needs. And we also can have maybe, I don't know, maybe the number of pages or something like that. Like, so I can say integer number of pages. Okay. And now we have our structure right here. The thing is that we have to define this structure outside our method. So we have to define it as in a global variable because we're defining a new kind of an object. And of course we have to end the last bracket with a semicolon. And now we have defined our books structure. Okay? So that's basically how we do it. Now, if we want to create an element or an object of that structure, we're gonna say, for example, struct books, and I'll call it, for example, book one, right? So this is the first structure we will create. So we have defined this, and we can maybe copy a string or something like that to the title. Okay, so we will include the string library that will enable us to copy strings. So you're gonna say include string.h, as you can see. So now that we have included this library, we can do the following. We can say strcpy, which means string copy. And here, the first thing we will put is the destination string. So in this case, it's book one. But if we want to access the title, what we do is that title, as you can see. So we're accessing a feature inside books. So say is string copy book one dot title, which is the first parameter or the destination of the string copy method, and the source will be, for example, this is my book name, or your book name, right? So that's the first title, right? Now maybe we want to continue. Go ahead and copy the author. Okay, so you're gonna say book one dot author, and we will pass as the author maybe Jack Jack, just the name, right? The name of the author. Okay, and so now we can also do the number of pages. In this case, since it's just an integer, we don't need to use a string copy. So to set that integer, we're going to say book 1 dot number of pages, and maybe we will set this to 104 pages, right? So now we have our book 1 initialized, okay? And we have that object ready to be used, right? So if we want to, for example, print the book title, we will do the following. Print f will print a %string and a new line, and what we'll print here will be book 1 dot title. Okay, so let's run it to check if this works. cc to run and .c1, cc to compile and .c1 to run. And as you can see, this is my book name is now printed on the screen. Okay, so we can do the same with the book author and the number of pages of our book. Okay, so this is how structures work. So you can be very creative on how to define structures. For example, if we define a structure, I will define a square, for example, right? And inside this, I will define an int, and for example, the x point, xo, for example, x0, and I'll set it, I cannot initialize it, so I can only define here. Okay, so int x0, and I can also say int y0. So this can maybe define the origin point for a square, or maybe it is a circle, right? So if it's a circle, we can do something like a struct circle, okay, and we can define something like its origin again. So you can say int x0 and int y0, and we also can define maybe the radius of the circle. So I can say int radius, and we can also define that, okay? So we can then access and create something like a struct square1 or something, or struct circle1, and we can continue doing this, right? So this is how basically structs work, okay? So if we want to, for example, continue learning about structs, so we have already learned how to define them and how to access them. But what if we want to modify them with a method using kind of pointers, right? So I'm gonna say here, I will define a method that say void modify struct, okay? Or modify book, if you want to make it easier. So modify book, and inside here we will have to get a structure type. So we have to get a structure type. To get a structure type right here, we do the following. We'll say struct, okay, books, and I'll call it book, okay, like that. So this is how we can modify our structure, right? But the problem here is that, well, we can do two things right here, right? So we define the method there, and we will actually implement it right here. So you can say void modify book, and I have to do the same as I previously defined the method. So here is books, book, so exactly the same, right? Okay, awesome. So if I open this right here, I could say, for example, I will just modify it by saying, for example, book that title. So So I will string copy, right? So strcpy, and I will say book that title, and I will say something like title or modified title, right? So now I'm copying it to this new book right here. So I will, of course, after this line in the main method, we printed the book title. We will go here and modify book. Okay, so I can say modify book, and what I will pass right here will be, of course, our book, which is called book 1 in this scope, right? So let's try to run it and see how this behaves, right? Okay, so I'm compiling it and running it, and as you can see, we cannot see the change because we're not printing, so let's print something. After we modified the book, we will print the title again, right? Okay, let me see, and we will print the same we printed previously, which is book 1 title. So just to recap right here, we're printing this title, we're modifying the title, and we're printing the title again to check if it was modified, right? Okay, so if we do it, we do here, and what we see here is that the title is not being modified. So you may ask why. So the thing is that the following happens. We are passing an object, okay? What does it mean? This means that when we are calling modify book and we pass the book 1 parameter, we're not passing the same book 1 right here. We're passing another book that has the same contents, okay? So we're passing another book that has the same contents. What this means is that the book that is received here, this right here, the one we are modifying in title, we are modifying the title to a copy of this book. Okay? To demonstrate this, I will print the new book title right here. So I'm gonna say print f, and as the first parameter I will pass of course %s and new line, and as the second parameter I'll pass book title. Okay, so now we will run the app to check if it works, and as you can see, it now works. So this is my book name, then we have modified title, and now this is my book name. So to illustrate this better, I am printing the original name right here. Then I'm modifying the name and printing the new name. But when I print it back, it prints the previous name because I have sent a copy and the previous name wasn't changed. So it was changed only in the copy I sent it. So how can I modify it in the actual original book? So that's the question, right? I want to send the original one and not a copy. So how can I modify it? So to modify it, I'll have to send a pointer to the original book. So how do I send a pointer? Well, pretty easy actually. So first of all, we have to modify our method definition and implementation to not receive only a book, but we have to enable it to receive a book pointer. So we just add an asterisk right here, and of course, since this must be the same as this one, we will add an asterisk right here. Okay, so now, as you can see, we can delete this. Well, we will delete the printf, okay? We'll delete the printf inside the modify book method. And right here, instead of passing book 1, which means copy, make a copy of and pass it, we will say pass the address of book 1, which is ampersand book 1, right? So what this is saying is first, okay, we printed the original title, then call modify book and pass the address of this book, when we pass the address, and then the method knows where the original book is located, so it won't create a new copy because we're passing just the address, right? So, and here inside the modify book method, we have to modify the new using the reference to the original book. Okay? So, how do we do that? Well, we basically do the same, but when we access through reference, which means when we access a structure through reference, which is what we are doing right here, instead of value, we, instead of putting a dot right there, we put a minus and a greater than sign, which kind of signifies an arrow. Okay, so this, I will call this an arrow that says inside book go to title. And you have to remember here that we use dots when we pass a copy of the object, and we use an arrow when we pass the address of the original object. So right here we're modifying the title, we're not printing the title here, so it will go back here and print the title if it was modified or not. So now I will compile the program and run, and as you can see, it now works. So it says this is my book name, and then we have modified title. So make sure you practice this a bit because this concept is really important. So first we say, please give me the address of book 1, and send that address of book 1, send it to modify book. So modify book knows where the original book 1 is located. Even though here we call it book, it's referencing to the original book 1 because it has the address of the book 1 structure. And to access that structure element, so the title element of book, when we are using a pointer or a fast variable reference, we use this arrow, okay? And we change the title the same way we did previously. And so this is how we access methods and how we access the structure parts using the address of the instruction, right? So this is basically on how structures work, right? So that's useful. And now let's continue with the tutorial. I will delete this code. You can create a new file. It's really easy, so you only have to have a main method, okay? So I will delete all of this because we've learned this already. So structures were learned. And now what we will learn will be dynamic memory allocation, okay? So when we create an array, like a character array, and we say char my array, and we set it to 100 elements, okay? Which will work, right? This will work great, so we can delete this string. Okay, so this will work just as we want. But what if we want to work in a more complex project that needs more memory, right? What if we want to create 1,000, 1 million, 10 million characters? Maybe to store a large video or image processing or do heavy tasks. So how, or even games, how do we do that? So the system won't be able to allocate millions of bytes, right? So if I tell the system to allocate, what is these numbers? So it's 1,000, 1 million, 10,000 million, so which is a lot. So let's decrease this a bit. So we're gonna want to allocate 1 billion bytes, right? If we want to compile this, and if we want to access the elements of this array, it won't be able to access it, okay? Because this number is so large and the program cannot allocate that much memory. If we want to allocate that much memory for some reason though, we have to include the standard library. So you can say include std leave.h. Okay. And how do we allocate memory? So what does allocating memory means? Well, basically we ask the operating system to give us a place. We can use the memory of that place, right? So maybe to do that, we're gonna create a char pointer. We want to point it to a memory place, right? So char pointer, and we will call it memory, okay? And we will set that to malloc, which is memory allocation, and we will tell malloc how many bytes do we need. If we need 1 byte, if we need 10, 100, 1000, 10,000, okay? 100,000, 1 million, 10 million, 100 million, for example, right? So if I go and say memory allocate 100 million bytes, then the system will return a pointer to that memory chunk, okay? So now we have allocated memory and we can start doing some stuff in that memory, right? So we maybe can create a while loop or a for loop, for example. So let's create for int I equals 0, okay, I less than 1 million or 100 million, or actually we can make our lives easier by defining a const int mem size, and we'll set this to 100 million, right? So 100 million, which is a lot of memory, right? 100 million bytes, and we will set malloc to mem size, okay, and we will set while I is less than mem size. So we should not write after the system memory that was given to us. So we can only use up to this point, right? We cannot go beyond. If we want more memory than this, we have to allocate more, right? So inside here, oh, I forgot to put I++, so I++. So inside here, we can maybe write some stuff to our memory cells, right? So you can say memory at I, and I'll set that to X, for example. I will set all the letters to X, right? So I can do it, and now I will run the program, and I will say I will print f memory was filled with X's, okay? I will print also, of course, a new line. Okay, I will compile it and I will run it. And as you can see, it takes kind of a second to fill memory. So it's not immediate, but it takes a bit because we're again using 100 million X's. So we now have 100 million X's. That's a lot, right? If we want a billion, so I was gonna create 1 0 more right here. And we will use a billion, so it takes some time. And after that, it says memory was filled with X's, right? So this is how we allocate very, very large amounts of memory, right? But now we have to free the memory after we have used it. So right here, we have to use that memory somehow, maybe whatever the app may does, like processing video, rendering stuff, or I don't know, any algorithm, whatever the case may be. And after we have used the memory and we don't need that memory anymore, we have to tell the system, hey, here is the memory you give me, and now I don't need it anymore, so you can use it for something else, maybe for another application, okay? So to do that, we only do and say free, and we pass the variable name which is pointing to the memory allocation we did previously. In this case, it's called memory, right? And now the system will free that memory, and we won't produce any memory leaks because we're freeing the memory we asked for. Okay, so that's what malloc is. But there's also calloc. So instead of malloc right here, we can also call calloc. What does it mean? Well, it means that it will initialize our memory to 0, but to call calloc, we have to, of course, we first pass the memory size, and then we pass the kind of bytes per the size of the data type. Okay, so char has 1 byte, so it'll pass 1. But when this is more useful, the second parameter, when we are, for example, allocating integers, right? We maybe are allocating integers. So we will decrease, right, 10 this because it will be too much, right? So if we want to allocate integers right here, I will pass int right here. And if I pass 1, it will give me 100 million bytes, but I need 400 million bytes because each integer has 4 bytes each, right? So I have to pass here 4, right? So why integer? Maybe some applications need integer to store pixel values, RGB and alpha channel values. So it would be useful for that. So if we can also do this, and if we run it, it will do the same, right? So we have malloc and calloc, and after we use both, we have to free memory in a way of telling the system that we are done using that memory, and now that the system can use something else. Okay, so that was memory allocation. Now let's learn a bit about the type definition, right? So we can create a new type definitions right here. So if you want to access the most primitive data type, which is an unsigned char, which is a byte, an unsigned byte, which is just plain 8 bits, nothing added, nothing more, nothing less, okay? But you say unsigned char is a kind of a long name. Why they just didn't call it byte, right? So we can define a byte by saying type def unsigned char, and we will give our new unsigned char name. We will call it, for example, byte. Okay, so how can I use this? Well, let me delete these guys right here. So instead of using unsigned char, I am a bit, okay, and I'll set it to 0. I can just do the same by saying byte, and this will be also I am 8-bit, and to avoid confusion I will call it 1, and I'll set it to 0, right? So this second way here looks much more elegant than this one right here. So we're using these in a very, very simple way, and of course it will compile. So if you want to test, just run it and it compiles. So we are using the byte keyword to access this new definition that we have done, right? Okay, so that's how we define a new type, okay? So as in other programming languages, we have true and false, but in C we don't have them. So for example, we can define it in the following way. So we can, for example, put number sign, and then we say define, and I'll say true, and I will call it 0, and also define false. It can be uppercase, it can be lowercase. I'll call it true is 1, sorry, and false is 0, right? So now instead of checking, for example, if if something is 1, we can just check if I am bit equals to true instead, right? Which is more readable if you want to do it anyway. It's not a must really. So we have learned a couple of useful stuff right here. And that's it for this video. I hope you enjoyed it, and I see you in the next one. Bye.